Okay, so you definitely need your calculator out today. We're going to be talking about the fundamental theorem of calculus again, but in a little bit different way. So get that out and let's get started. So basically, when I have the derivative already, so I have a derivative and I have some point already known, and I want to find the unknown point. Okay, I need to do the fundamental theorem of calculus, but we're not going to do it where we've already learned. We're going to do it where we like set up things like the full long way, the full long equation. So I'm going to say that the integral from 2 to 3 of the derivative equals, and I'm going to go ahead and put what it would be in general. It would equal the antiderivative of the 3 minus the antiderivative of the 2. So this is kind of like this longer setup, and then we're going to say, hey, go find this, typically in the calculator, but not always. This is one you could do either by hand or in the calculator, okay? But you would get 24. And we're going to say that equals what we're trying to find minus what we already know. So this would turn into the plus 1, right? Because minus a negative. And now I can say that I'm going to subtract the 1 over, and I can find what that value is. And that's basically what we're going to be doing this whole day for notes, okay? Really solidifying it. This is a concept that is huge, and we want to have down when we're given a derivative, given a point, and we want to know the output of another value, okay? So here it says, all right, we've got the derivative of an x, we've got the derivative of a y, we know what happens at an x, so we've got a point on an x, we've got a point on a y, and now we want to know, hey, what's going to happen when the time is 3? What is my now output here? So I know that when time was 0, was 0, negative 4. I want to know what is it at 3? So we need to go find the x at the time 3 and the y at the time 3. So I'm going to start with the x. I'm going to put the derivative here in the middle. I'm going to use the value that I already know of the time and the time that I am trying to find. I'm going to set it up with my formula. This is the x of the output of 3 minus the x of the output of 0. Then we're either going to do this by hand or in the calculator. You pick. So if you want to do it in the calculator, let's go for it. Let's practice that. So go math, 9, 0 to 3 of 4x plus 1 dx, and I got out 21, equals x of 3, what we're trying to find, minus x of 0, which we already know. Well, that one's pretty easy to figure out. That would give me an x value of 21. So now let's go and set it up with the y. So I'm going to put my derivative in the middle. I'm going to put the value that I know, the value that I want, and then, oops, that's not an x now, that's a y. What that would be, move this, let me move me out of the way. Okay. So now I'm going to go ahead and put that in the calculator again for this part over here. So math 9. And I got out 0.77356. Make sure you get the same thing. And then minus a negative 4 would actually be a plus 4 here. So I subtract that over, and I can see that y of 3 is about negative 3.226. So if I was looking at the point, you could leave it like this, or now you can say, this is where I'm at when t equals 3. Okay, so I want you guys to go ahead and try this from the 2003 AP test. So I want to know the velocity at 2. I know the velocity at 1, and I know the derivative of the velocity. It's that acceleration. So get your setup. Put the value that you know and what you want. And I like to always put them in order. So 1 comes before 2. And I know that the antiderivative of the acceleration is the velocity of 2 minus the velocity of 1. Go put that into your calculator. What I'm trying to find, what I already know, and then add over the 2. That's an approximation on these guys. And there you have it. So let's do this same kind of concept with a graph now. Here I'm given a point, and I'm given the graph of f prime. And if I want to now find f of 0, so I'm going to put the prime, which I don't know the function, but I know I'm looking now from -2 to 0, and I know that that's the output of -2 minus the output of 0. Now I can't put that piece in the calculator because I don't know the function. So I actually have to go find -2 to 0 on the graph, which we can do. So that's 1/2 base times height, and I got out 4. I know this guy was 5, and now I can go find, oops, I just wrote that backwards. Are you guys yelling at me yet? That's f of 0, f of b minus f of a, -2. Ah, okay. So f of 0, which is what I want to know, minus f of -2, which is 5, and I get out 9. So do that for the other guys and see if you can find f of 2 to be 13 and f of 6 to be 13 minus 2 pi. If you'd like to do more of those, I'm going to go ahead and give you the answers and let you try. This is a really good one. This says that this is 4, this would be 9, which is kind of like a negative, and that this is 2. This is actually easier than the one before. So see if you get out 1, -4, and -2 for a little bit more practice with the area if you feel like you need it. Okay. Let's do the next page. Pizza temperature when time is 0. Okay, so at time 0, I know I have a temperature of 95. So I'm kind of given that point. And here is the rate. So here's the first derivative. And I want to know what's the temperature at 5. So I'm looking for another point. So I have a point, I have a derivative, and I'm looking for another point. Fundamental theorem of calculus all set up. So I'm going to go from 0 to 5 of the derivative. And this would be the antiderivative, whatever you want to call it. I'm going to call it the temperature, so T, okay? The temperature of 5 minus the temperature of 0. Put that part into your calculator. This is what we're trying to find. This we know is 95. Add over the 95 and see if you get about 71.392. That was in degrees Celsius. All right, I want you to definitely try these next two and see if you can get them on your own. And if you have questions, please, please, please let me know. And then there's one more if you need some extra practice with the graphs or not, feel free to try that as well. I'm gonna go ahead and give you these answers. So if you're like, I really wanna try some more, I need a little bit more review, see if you can get this. All right? Hey, I will see you guys in class just a couple more days.